Hi, in this video I'm going to show you how to download data into a CSV file and then import it into VPython so that you can compare your video data to the accelerometer data. So the first thing we need to do is get it into a format where when we download it, VPython can easily make sense of it. So I'm just going to take my X and Y positions and I'm going to copy and paste them into another sheet. And now I just have X and Y positions, no headers, no nothing. Now there are some ways that we could deal with labeling the columns and that type of thing and get it to still work in VPython, but I'm just trying to keep things as simple as possible right now. So I'm just going to go to File and then Download as a CSV file, comma separated values. And then once that's downloaded, I need to make sure that it ends up in the exact same folder as the Python file that I'm modifying, as well as the physutil files. If you're doing this in Excel instead, on your home computer, it really should work, unlike how it played out in school. But just make sure that you save it as a CSV file, and then make sure that it ends up in the same folder. Alright, once you have your file saved as a CSV file, you can go into your Python folder, or your Python program, and we're not going to change anything up here except for this one thing here. So this mass 2, is going to represent the position of our hanging mass according to the video capture data. I made it a different color, blue, instead of red. And I also oriented it sideways rather than vertically. And this was just to make it very clear what we were looking at. As far as the mass goes, I have a mass of 0.2. Position vector, everything here remains the same. The only thing that's different is when I get down to this import position data. So I'm going to just highlight all of these things here. I'm going to go to Format and then On Comment Region. And so that just gets rid of all the commenting, at least the first layer of it. And so what this says here is I'm going to store as variable X and as variable Y the first two columns of the CSV file. And I think I called it car hang mass. Actually, I called mine car cliff hang. So I'll type in here the name of the file that I want to pull the data from, car cliff hang, and I want two columns of it, and I'll store the X position as X and the Y position as Y. And then I have these two other variables here, and this is the index. And the thing about the way that Excel works and about the way that Google Docs works is that they're index-based 0. So the first, at least in this sense, so the first column is column 0, and the first row would be row 0, and all subsequent rows are counted off of that 0. So this is going to indicate that we use index 0 first. And then this count variable, CNT, is just to keep track of how many times we've gone through our model, and once we get up to 7, we're going to put in the video data, the video analysis data, in the next line, or from the next line. So for every 7 model calculations, we're going to have one X and Y coordinate updated from the car cliff experiment, or from the car cliff video analysis. So nothing here changes until we get down to this point. And I'm actually going to ask you to make a couple of edits to this. I realize that there's a little bit of an error here. And there's also something else that doesn't make any difference at all. So I just uncomment that out. And you can see here that the first thing that I do is I increase my count. And that's because I've gone through one round of model calculations, and so what I want to be able to do is update all of this. So I want to say that I've gone through one model calculation and update. Now I have while the count is greater than 6. So once the count reaches anything better than 6, which would be 7, we're going to do the calculations that are in here. So the first thing it says to do is update the index. So we're going to look in and update the index here. And after we update the index, I'm going to say that the position of mass 2 is equal to a vector, which is described by the X position of that row, the Y position of the current row, and Z position of 0. This was for something different, so that's not relevant. And then we set the count, how many model updates we've made since the last representation of our video capture data. We're going to set that back equal to 0 because we haven't updated the model at all since we've just done the update due to the video analysis. Alright, the last change that needs to be made really only needs to be made if your initial position is substantially different from 0, 0, 0. So if we have our initial position in the x and the y are quite different from each other and from 0, then what we need to do is we need to put in an initial position for mass 2. So what we want to do then is where I have mass 2 here, I do dot position, and that's going to match up with the syntax that's used later on, and it's kind of a built-in aspect of boxes and that type of a thing where we want to indicate where they're located. The default is going to be 0, 0, 0. So if we don't indicate any other position, that's what it'll do. But what if your initial y position was something like 0.8 meters high or something like that? So what we want to be able to do is have a little bit more flexibility. And so I'll make a vector, and I'll read in the very first line, line 0, for the x position and line 0 for the y position. And this will now specify, before we start to do our calculations, where the stuff is located, at least initially. As I said, if your initial position is 0, 0, 0, it works out alright. Otherwise, you need to do this line of code here. One last bit, and then I'll finish this video up. I noticed that I did make that 0.1, and so now when I run this, or 0.01, so now when I run this, you can see my video analysis, and you can see my accelerometer model data. And there's clearly some sort of a divergence taking place here. If I want to see more specifics about what might be going on, I can make a graph of their positions versus time. So I'll just briefly show you how that might work out. So I go down here, and you can see that I don't have any sort of a graph lined up. But what I can do is I can add that in. So the first thing I'm going to do to add in a graph is just go up to the top of the screen under Visualization and Graph Setup, and I'll just add a graph, and I'll call it graph, and in order to make the graph I have to call a function called physgraph and identify how many things I want to plot on the graph. So once that's done, I'm going to go back down into my embedded while loop, so the while loop that updates the video capture model, and I'm just going to put in graph.plot, and then I'm going to put in time. That's my x value, and in my initial instantiation of this, that's what it's called when you make things, I said I'm going to have two y-axes, or two y-axes variables. So my two y-axis variables are going to be the position of my accelerometer model, base model, and the position of my video capture. And when I plot this, then it's only going to update once every 7 times the model actually updates, but I'm only going to see the video capture model that often, so it seems appropriate to put it there. And then when I run it, we can see that there's definitely a divergence between where these end up. It's unfortunate that the colors are what they are. I probably should have switched these around. But in any case, this is the accelerometer data, or model based on the accelerometer data, and this is the video capture data. So we can see that there is clearly a divergence in where they are. If I want to find exactly where they are, approximately, I guess, not so much exactly, I can just hover over them and find out where they are. So that's the gist of this exercise. Hopefully it makes sense. Hopefully you're going to be able to pull this off. I know there were a handful of changes that I suggested, but if you go back and watch the video and just kind of copy what I did, then you should be able to do it, and hopefully it also makes sense. In the next video, what I'll do is just briefly show you how to do this with the cart when you varied the cart. So you have the script for varying the cart, and then in the final video set we'll just be kind of going over the traffic light incident model that I made, and that'll be a couple videos taking you through that.